Welcome to MEI Numerical Methods Introduction. In this video we'll be carrying on looking at errors and rounding. Now, using the same notation as previously, so that little x is the exact value for some quantity that we've measured and big X is an approximate rounded value, then if in this case we're told that big X is 12,300 to three significant figures, then we might be interested in trying to decide what could be the possible interval for the true value little x. And we see that the smallest possible value for little x is 12,250 and the largest value is 12,350, because anything in that interval rounds to 12,300 to three significant figures, and anything outside the interval rounds to something else, to three significant figures. If it had been four significant figures and our big X was still 12,300, then the smallest possible value could be 12,295 and the largest possible value 12,305. So that would be our new interval. Now, supposing we happen to have an interval estimate for a variable little x, so that we've been told that it lies between 0.9876 and 0.9888, and we want to be able to quote little x to a certain number of decimal places, then we can see that both ends of the interval round to 1.0 to one decimal place. So we can certainly quote x as being that value to one decimal place. But it's also true that 0.9876 rounds to 0.99 to two decimal places, as does 0.9888. So we can do better than one decimal place and say that little x is 0.99 to two decimal places. However, at the left-hand limit to three decimal places rounds to 0.988, whereas the right-hand limit rounds to 0.989 to three decimal places. So we've got differing values within that interval. Some round to 0.988 and some round to 0.989. So we can't say definitively that little x is a certain value to three decimal places. In this situation, we can't actually quote little x to any number of decimal places, because the left-hand limit rounds to 2 to no decimal places, whilst the right-hand limit rounds to 3 to no decimal places. But what we can do instead is to take the midpoint, 2.47, of that interval, and that's going to mean that in the worst possible case, if little x was at either extremity of the interval, then we would have kept the error to a minimum. Now, suppose that we're interested in the relative error, and we've got our approximate value of 2.47, and if we consider the worst case scenario, bearing in mind that for the relative error we've got the true value in the denominator, so in order to get the largest possible relative error we want the smallest possible value in the denominator, so we're going to need to have 2.36 in the denominator. So dividing the absolute error, which is that's our x, big X minus little x, by what we're assuming in the worst case scenario, what we're assuming little x to be, that gives us the highest possible value for the relative error. Now, there are a few rounding issues to consider. The first one is premature rounding. This is where in some calculations you've you've perhaps taken a figure from a calculator, or a computer might have worked out a figure, and if we don't retain enough decimal places, then this can affect the answer. So that as a general rule, you want to keep at least 2 more decimal places than you're going to round to in the final answer. And then another issue is progressive rounding, which should obviously be avoided. This is where we take a value of say 1.23456, and we can round that to 4 decimal places to give 1.2346, and then what we mustn't do is round it again to 1.235. So at the moment we haven't actually deviated from the if we were to round the original figure to 3 decimal places, that would also give 1.235. But if we carry on rounding, so we take our 1.235 and round that to 2 decimal places, and now we've ended up with a figure of 1.24, which is not the original figure rounded to 2 decimal places. And finally, we have the issue of chopping. This is something that might take place in a computer if it hasn't been programmed very well, and it's all it means is that instead of doing sort of proper rounding, we're just losing figures after a certain point. So that concludes the video on errors and rounding part 2.